Alright, this is part 5, Soil, the home for plants. We'll be talking mostly about nutrient deficiencies in this section. So, nutrient deficiency symptoms. A lot of these examples are kind of textbook, I'll be honest. And in reality, it's usually not just one nutrient that's deficient in a plant that you may see as a sample brought to you as a master gardener. It's usually a combination. But these are some good examples of what you might see or have seen in your gardening endeavors. This is nitrogen deficiency. Now, I'll explain some things about the nutrients. Some of these nutrients are mobile in the plant and some are immobile. Nitrogen is a mobile plant nutrient. In other words, it can go from the lower leaves, the older leaves, and move up to the very tips or the newest leaves that are being formed. It's mobile within the plant. It's not locked into the cell structure. So nitrogen deficiency starts showing up on the lowest leaves first. So when people say I have yellowing leaves, are they lower leaves or are they upper leaves? Lower leaves, my first thought, may be nitrogen. But just because a lower leaf is turning yellow may not equal a deficiency. Think about what else may be causing that leaf on the left-hand side of the upper picture to be turning yellow. Yeah, it could be just an old leaf that the plant is shedding. That may be a normal thing. And some plants just have typical times of the year when they shed various old leaves. So knowing when a plant might shed leaves, even evergreen plants will shed some leaves usually at some point in their life. But the green, the loss of color is fairly uniform. Notice that you don't see any pattern. Let's look at the second from the left. It's kind of a limey green color. You see the veins, but they're still also more or less that limey green color, as is the one on the second from the right, and the one on the far right is uniformly dark green. That's one of the newer leaves, so it's not showing the symptom. It's a progression in some cases. Sometimes the leaves will be thickened and a bit brittle, but that's very hard to delineate, I think, in most cases. Nitrogen deficiency may cause a plant to be stunted in its growth. However, there could be other reasons for that. If a plant wasn't planted properly and that root ball broken up at the time of planting, it may be stunted because the root system hasn't spread beyond the confines of the container that it was originally in. Thinner or sparse foliage may also be a symptom of nitrogen deficiency, but that could also be due to the general health of the plant, or maybe possibly disease issues for that matter, or maybe they've pruned it improperly. So again, it's sometimes very hard to spot some of these deficiencies as easily as we see in these photographs. When plants are deficient in many nutrients, they're more susceptible to be stressed out. Now look at the lower little twig there. We can see a uniform yellow, but that could be due to some other reasons. It could be that that plant has been girdled around the stem, for example. It would be very hard to say that was nitrogen just by the photograph there, but that's what we're looking for nitrogen deficiency. Phosphorus deficiency, this is fairly rare in the state of Florida, as we mentioned. I'm using citrus for a lot of the examples because they're some of the best photographed and documented for deficiencies. A dull cast to the leaves. I've never seen that, and I really wouldn't know how to quantify that beyond that. You might see a reduced leaf size, but there could be other reasons for that. Again, it's rarely a problem. Here, what they're showing in the citrus is those that are deficient in phosphorus have a thicker peel. Uh, with citrus issues nowadays with greening, there could be a lot of reasons why there's a thicker peel and less fruit inside, probably due to greening versus phosphorus deficiency. Again, I can't remember a time I was able to diagnose a phosphorus deficiency. This is potassium. It's also seen on the lowest leaves first. This is because it's a mobile plant nutrient. So the oldest leaves can push out through into the phloem the potassium and it move up into the newest forming leaves. Interveinal chlorosis. Chlorosis is a $10 word that means yellowing. So in between the veins, interveinal, yellowing, or chlorosis. Marginal leaf scorch. I'll show that in another picture or two. Irregular necrotic spots. That would be very hard to diagnose potassium deficiency from that. Blue-green leaf coloration. I have not quite seen that. Here in the photo set with citrus, one of the symptoms before greening was established in the state of Florida was smaller fruit. Nowadays, smaller fruit is generally a correlation to the decline in the health of citrus due to citrus greening and the Asian citrus feeding on the plant and infecting the citrus. You may have seen potassium deficiency in our palms. Again, the lower leaves will be affected first. If it's not too severe, you get these translucent, kind of this yellowy orange flecking. Now you might think that were a disease, and it does kind of resemble disease symptoms. But it's translucent. If you were to hold this up to a light source, you could kind of see through it like stained glass. Again, this would be primarily on the older leaves, where the newer leaves would be green and healthy. And here it's the beginning of potassium deficiency on a palm, a pygmy date, I believe. You can see the marginal tips, that chlorosis, that yellowing. Notice the rest of the leaves, except for that first row near the base of the plant, are unaffected. That's because the potassium is moving from those lower leaves up to the newest leaves, and they appear green and healthy because they are. Now, what do people start doing when they see the yellowing of this leaf? Yeah, they start removing it. So they remove it to improve the aesthetics of the plant. But meanwhile, what are they robbing the plant's bank account of? They're robbing it of potassium. So now they remove the lower row of leaves, and then a few weeks later, the next row of leaves are going to be start to be tapped in for the potassium if the plant is actively growing. So those leaves will start turning yellow. And what do people do? They remove that. And then when that row of leaves turns yellow, what do? They keep on taking them off. So our recommendation on palms is not to remove a frond unless it's brown or dead. We'll talk more about that in palm nutrition and palms in general. Now as it keeps on progressing, we'll see that the tips of those leaflets start to turn brown and die for lack of potassium. That's on a pinnate leafed palm here in the upper right hand photograph. On a palmate leaf palm, you'll see the tips of the frond starting to get the flecks or turning brown. This is go back a second on iron. Notice it's symptomatic on new foliage. Iron is immobile in the plant. So once it's locked into the cells and the plant tissue of the plant, it's there for the rest of that leaf's life. So when the plant cannot get enough iron for whatever reason or reasons, the new foliage will come out showing the deficiency symptoms because it's an immobile plant nutrient. This one is magnesium deficiency. This happens to be a holly tree. They're notoriously showing deficiencies of it. Again, maturing leaves first. The old, you can see it. Often appears mid-season. Initially unconnected chlorotic areas. I haven't quite seen it that way, but the classic is what we call the inverted V shape at the base of the leaf. Notice where the leaf was attaches to the stem, there's a V shape, but it's not upright, it's upside down. Now, this can be mistaken for some people as a variegation because it's so sharp in its delineation. But when it comes to variegation, it's not an inverted V. Magnesium deficiency. This is very common, and when you drive around after seeing this module, you'll diagnose it all over the place, especially on our phoenix or our date palms, especially those with the pinnate leaf form, as you can see here. This is very common in Florida, with date palms being extremely susceptible. The symptoms begin on the oldest leaves first. That's because it's a mobile nutrient. Those lower leaves are being robbed of that magnesium, moving it up to the phloem, through the phloem up to the newest growing leaves. So the new leaves look perfectly fine. Typically a light yellow band along the margins with a green center. Almost looks variegated, doesn't it? Here's an overall date palm from further away. You can definitely see that it's green down the center and the leaflets near the tips are bright yellow. Now that's in a pinnate. In a palmate leaf, you can see the same thing. It just looks a little different because of the shape of the leaf. Best way to treat this is preventatively. Now a lot of people know about Epsom salt. Epsom salt provides magnesium sulfate specifically. But dumping on a whole bunch of magnesium will not fix potassium deficiencies and some of the other deficiencies that I'll talk about in palms in a lot more detail when we do our palm section. Frizzle top, I do see this from time to time. It is on the newest leaves first. It is a manganese deficiency. Epsom salt provides magnesium. Manganese is a whole different element. It's common to see this in our alkaline soil, especially on the west coast of the county. The newest leaves appeared withered or scorched or frizzled. Some people may misconstrue this for drought issues. It is simply a deficiency of manganese. Now, this nutrient deficiency in palms especially will be fatal if it's not corrected in a timely fashion, as those older leaves will eventually die and leaving the plant with no living green leaves. You may have seen frizzle top on a king sago, parenthetically a palm, not truly a palm, but for reasons I can't tell you. Palms and sagos, palms have similar nutrient deficiency symptomology and also nutrient needs. Again, notice how the newest leaves came out and they look all burned or something. Again, people want to try to correct it after the fact. It does need supplementation, but this will be very hard to get this to correct itself for 1 to 2 years. But what do most people start doing if they take off too many leaves? They kill the sago palm. We also will see this in queen, but not as often as I see it in sago and some of our other palms. Here is manganese deficiency and a dicot. You can see it's intervenal chlorosis. I'd be very hard pressed to diagnose that as manganese deficiency. It is definitely one of the micronutrients, as most micronutrient deficiencies show this classic intervenal chlorosis, where the space between the leaves is yellow or light green, and the veins remain a fairly prominent green themselves. Here's iron deficiency on several different plants. The upper right-hand picture appears to be a citrus. You have some interveinal chlorosis. This leaf almost may be deficient in nitrogen as well, but it's hard to tell. Classic example is the lower left-hand photograph of azaleas. Notice the one on the extreme left. The lowest few leaves are nice and healthy green. Then you see that big new flush of growth that's showing interveinal chlorosis. And you can see a spectrum of minor amount of deficiency to a major amount of deficiency as we go from left to right. Most people will cut the yellow leaves off, making things worse. It's best to supplement with iron, preferably through the leaves because micronutrients are best absorbed through the foliage. Here are some palms, hard to say which one, but the interveinal chlorosis is that striping effect like a zebra of green and yellow in this case. So. I'll be honest, I've never seen a copper deficiency. This happens to be twigs of citrus. They get these pockets of gum underneath the bark and these lumpiness. I've never seen copper deficiency in any other plant other than these particular photograph sets. And here it is on citrus again. I would assume that was some mechanical damage based on the photograph from either banging around in the wind or for that matter thorns or something on the plant just damaging the peel. Be very hard to tell that's copper from a photograph. Zinc, again, it's a micronutrient, but always important. It also has interveinal chlorosis. Zinc, usually the veins are a little more prominently green and wider in the green, rather than a very narrow like we saw with azaleas. But again, micronutrient deficiencies are hard to determine one from the other. But again, notice the newest growth is affected with the micronutrient deficiencies because they're immobile nutrients. I have seen boron deficiency, and this is one of those that happens when we get heavy rains for multiple weeks or months during the growing season or the summer months here in Florida. I haven't seen the upper right hand picture, that zigzag look or fish hooks, if you will, nor have I seen quite the lower picture with that um, almost like accordion like look. I'll show another couple of pictures, but again, this is boron and it's going to show in the newest leaves that are trying to form or unfurl. And here's some more interesting pictures, but the lower picture I have seen before. It almost looks like somebody either cut the leaf or try to do the paper dolls, and they get these almost like holes right there where it looks like it was folded and someone tried to cut it out. I don't know why it does that, but that leaf was unfurling, and then because it lacked the boron, those cells didn't form quite properly. I have seen that, and it's very diagnostic of boron deficiency. Now, another one is that spear leaves, the newest leaves, fail to open or bend over, but they remain green. This could be misconstrued for a disease of palms, which we'll talk about later. Now, the problem with boron is that a little goes a very long way. Plants only need a few parts per million in their tissue in order to be healthy and grow just fine. A little boron would correct this. A lot of boron will work like a herbicide, in other words, a weed killer or a plant killer. Generally speaking, when it comes to boron deficiencies, I recommend people don't do a whole lot to fix it, or they go very, very slowly with doing so. Again, putting a little on may help, but putting a little more than that will probably be fatal. I also have seen this symptomology in palms with this accordion folding of the leaves where they fail to unfurl, especially that lower picture. I have seen that from time to time. That is a boron deficiency. A lot of people mistake that for maybe insect attack or something like that as well. I've never seen this molybdenum deficiency. This is in citrus. Quite frankly, that dark spot with the yellow halo, I would have misidentified that as probably a disease symptom. So, again, this is a very rare one. You probably will never see it. I've yet to experience it where I recognized it off the bat. Now, if you're ever trying to figure out plant nutrient deficiencies in the plant clinic or at home or with your neighbor, when you Google around and things like that, looking for nutrients symptoms and pictures of them, you'll see a lot of marijuana plants, to be quite frank with you. Uh, Awfully well documented in the photograph world on the internet. guess people have some very interesting fascination with that particular plant for reasons we don't need to go into. But if you're looking for some really good ones that are not just the aforementioned marijuana, here's a couple of good websites that may be helpful in the future, especially with the palm nutrition. All right, again, let's wrap this up. Slow release fertilizers, we recommend 30 to 50% of that nitrogen being a slow release form. We usually recommend fertilizers which are low in phosphorus. We usually have ample amounts of phosphorus in our soils available to plants. I also recommend against using combination products such as weed and feed or fertilizer and insecticides. Usually they don't do a good job of one or the other. Applying less fertilizer more often to reduce the risk of leaching or runoff. We call that spoon feeding. So a lot of people will cut back at the amount that we know to apply and use only half, but allocate that out over the course of the growing season more judiciously. Ideally test the soil every year to figure out where it is and what it may need or may no longer need. Fertilize only when needed. Can't stress that one enough. Well, that ends Soil, the Home for Plants. I hope you've enjoyed it, and hopefully you've learned a lot more about fertilizer than you ever thought you knew was possible.